Hello everyone. Welcome to today's webinar on digitalizing the wire harness business. This webinar is brought to you from the Integrated Electrical Systems division of Siemens Digital Industries Software. My name is Shiva Arumugam. I am a technical product manager for the Capital Harness suite of products. I joined Siemens in 2020 after spending a few years in other roles in the automotive and wire harness industries in India and Germany, and now currently based in Munich. I hold a master's degree in automotive systems engineering and a bachelor's degree in mechatronics. As part of today's webinar, I will be speaking on the following topics. We shall begin by looking at some of the key challenges facing the wire harness industry, then look at the Siemens philosophy of the true digital enterprise, and lastly, look into how it can digitalize your wire harness business. The wire harness industry, for sure, has several challenges, but today's presentation will be focused on a select few of those. Let's now begin by looking at some of the key challenges facing the wire harness industry. The advent of industry megatrends like autonomous driving, electrification, shared mobility, and connectivity have caused a growing demand for advanced features and functionality within the automobile. These megatrends directly impact and create the need for a highly sophisticated automotive EE system, which emphasizes the wire harness. Of late, we are witnessing a tremendous increase in its complexity, content, and cost. We are speaking about thousands of possible wire harness configurations, over 3 kilometers of cabling, and about 60 kilograms of harness weight per vehicle. Not only is the product getting more complex, it is also generating big data as it evolves. This leads us to an obvious question. How prepared and equipped are we to manage such complexity? We understand that conventional wire harness design and manufacturing methods are starting to creak under the weight of the product complexity caused by automotive industry trends. The need to ensure availability of consistent data and its seamless exchange between stakeholders is very important. But this can be a tricky job, especially with traditional siloed domains and disjointed engineering and manufacturing systems. This clearly impacts overall productivity of stakeholders. Manual re-entry of data leads to error-prone and incoherent data throughout the flow, directly impacting product quality, and such mistakes cost money. This inadequacy also leads to longer cycle times and poses a serious challenge when it comes to adhering to budgets. Now, if that's the case with first-time designs, with the frequency of incoming changes we have today, change management for sure can be quite overwhelming. In a highly price-competitive industry like the wire harness business, manufacturing efficiency is paramount, as it can directly eat into the bottom line. Optimizing production could mean either before the start of production or during change implementation, with traditional practices like prototyping and physical tryouts can be time-consuming, unsustainable, and above all, unprofitable. The accelerating pace of program milestones also means that often engineers have little time to optimize the manufacturing process, leading to a suboptimal process. So most of the times, optimization efforts continue even after production has begun and can be even more challenging to optimize whilst ramping up. Tackling such challenges while remaining profitable calls for a complete business transformation. But how? The answer lies in digitalization. Digitalizing the wire harness business is no longer a question of should we, it's more about how fast can we. And this is where the Siemens Accelerator can be of help. Before we speak about how the Siemens Accelerator can help digitalize your wire harness business, let's take a look at the Siemens philosophy of a true digital enterprise. In a nutshell, it comes down to consequently combining the real and digital worlds with a comprehensive digital twin approach, and looking at the life cycle of both the product and production, thereby enabling a continuous loop of optimization. And with our digital enterprise approach, we do exactly that. By working with our comprehensive digital twin, you can integrate the entire product lifecycle and the factory or plant lifecycle, which were until now entirely separate worlds. The digital twin of the product enables interdisciplinary collaboration and concurrent development to create an accurate virtual representation of a new product in no time. It comprises the MCAD, topology, schematics, and the harness designs. The digital twin of production, on the other hand, comprises the manufacturing process design, a balanced distribution of tasks across workstations, and a virtual model of the shop floor, which is modeled to optimally manufacture the Y-harness. Such realistic simulation of machines, lines, and complete plants is the foundation for flexible and efficient manufacturing. By connecting the life cycles of the product and production, you enable a flow of data, which means that all the stakeholders involved in the development of the product, the planning of the production, and the production itself always have access to the right information. The digital enterprise integrates both life cycles seamlessly, and the generated data, or the performance as we call it, enables a continuous loop of optimization both for the product and production. Now that the product and the production process are designed, engineered, simulated, and validated in the digital world, we can actually make sure that everything works in the real world as planned and intended. The product design defines the engineering bill of materials, and by using the digital twin of production, the bill of process is generated. This way, the product and the entire production process can be simulated and validated well in advance, no matter where the product is finally manufactured. This ensures that it's always produced in the same quality everywhere, exactly according to the given specifications. What we have just seen is what we believe is a true digital enterprise. It's about having access to the unlimited power of data, gain valuable insights to make fast and confident decisions, and to create the best product and production. The comprehensive digital twin approach to design, simulation, and validation hence allows us to make it right the first time. Now let's see how the Siemens accelerator can help digitalize your wire harness business. Accelerator is a portfolio of software services and an app development platform that speeds up digital transformation. Accelerator enables customers to create their own comprehensive digital twin, flexible and adaptable to their own unique requirements and business models, using data and insight to predict and adapt products to future needs. For today's agenda, we shall look into the wire harness specific use cases from two unique products from the Accelerator portfolio, Capital and Technomatics Plant Simulation. Capital delivers the digital twin product. It comprises the architecture, topology, schematics, and harness design. And not only that, it also feeds necessary ingredients like the bill of process, the manufacturing bill of materials, and production line scenarios to design and validate the digital twin production. It also delivers manufacturing information and documentation like the form board drawings and operator work instructions required for use in real production. And plus, it delivers technical and diagnostics documentation required to maintain the real product throughout its life cycle. The most important point to note here is that none of these entities are isolated. They are all connected and supported by a coherent digital thread. Also, this data-centric approach ensures that all stakeholders always naturally have access to the right information. The use cases we will see today are focused on the left side of this quadrant, more on the digital twin product and its integration with the digital twin production, especially after a wire harness has been fully designed and engineered. For those of you who are familiar with Capital, the tool offers a powerful graphical harness design environment, enabling harness engineers to effectively capture and describe design intent to create fully detailed and validated harness designs rapidly and accurately. Such fully engineered harness designs are now ready for manufacturing engineering and costing. We shall now look into a few use cases, beginning with process design, costing, and balancing tasks in Capital, and later on, see the usage of the Capital bill of process and line scenarios to simulate production with plant simulation. Manufacturing process engineers are often faced with the challenge of determining an efficient pattern of sequence process steps that result in the correct assembly of the target harness. Usually, more than one possible pattern will exist. The optimum choice depends on the specific manufacturing capabilities of the factory or factories in question. Capital facilitates automatic creation of an efficient manufacturing scheme for each harness to be built by decomposing harness designs against previously captured descriptions of manufacturing capabilities using a reasoning engine that incorporates wire harness assembly logic. Process engineers can rapidly and accurately synthesize harness build processes, tasks, manufacturing times, and more from a harness design. An easy-to-use graphical process design tool generates multi-level builds of process and materials to feed downstream systems, thereby raising the efficiency of process engineers and reducing cycle times. Configurable operations, tasks, and factory models capture best practice process expertise that can be applied across multiple manufacturing sites, improving standardization. Automated identification of common subassemblies eliminates subassembly duplication and cuts manufacturing costs. Engineers can hence use Capital to capture and apply organizational IP and best practice techniques to manufacturing process planning and cost estimation tasks. It facilitates fast and accurate process planning, making time available for engineers to create multiple what-if scenarios to be compared with each other and analyzed for optimum manufacturing efficiency. The generated bill of process and labor times can now be used to distribute and balance assembly tasks across workstations. Manufacturing engineers can leverage capabilities offered by Capital to design efficient production lines, use existing manufacturing resources as effectively as possible, and quickly and accurately distribute manufacturing tasks across workstations on a production line. Tasks can be assigned to workstations by simple drag and drop functionality, with constant guidance showing the earliest workstation where a task can be performed based on predefined task and material dependencies. Warning messages immediately notify if a task is assigned to a workstation before the material is present or before a prerequisite task is complete. It lets engineers react quickly to new situations like change take rates, helps inform better shop floor decisions, and ultimately reduce the time to profitability, thereby allowing time for multiple scenarios to be compared and analyzed for optimum efficiency. Let us now see how the generated bill of process, labor times, and a balanced distribution of tasks across workstations can be used to simulate production. As we have just seen, a manufacturing engineer working with Capital was able to design the entire manufacturing process and can now seamlessly deliver the resulting information to drive the digital twin of production, built based on the specific manufacturing capabilities of a given factory. But before we can begin to simulate production using the plant simulation software tool, the plant model also needs to be fed with customer order and project relevant information like volume forecasts and take rates from an ERP system, for example. All this information can then be used to run a production simulation and virtually optimize production. All of this long before building the real production lines on the shop floor. Technomatic's plant simulation is a tool used for simulation studies and experiments of material flow, operations, staffing, and logistics in any type of production. Plant simulation equips engineers with a variety of tools and capabilities. 3D visualization helps validate and optimize production layout. Dynamic charts, on the other hand, let engineers monitor and optimize resource utilization. Sankey diagrams and bottleneck analyzer can be used to analyze and optimize material flow and throughput, while experiment manager and energy analyzer enable engineers to optimize the overall production process and energy consumption. We shall now look at some of these example use cases. There are several stakeholders, starting from the OEM to the Tier 1 harness manufacturer, that need to understand the layout and capabilities of a harness manufacturing facility. The 3D visualization feature lets users do exactly that and more. This can be a very useful tool to virtually build and visualize an entire harness manufacturing plant. For example, in case of a completely new production site, it can help starting from early conception phase with production layout design and CapEx or investment planning. Later on, it can be of significant help during the RFQ phase with shop floor square meter or space calculations. It can also be a powerful tool for harness manufacturers to virtually demonstrate production capabilities to customers or to propose where a new production line can be added to accommodate new product for a given customer. Today, most of this work is painstakingly done using legacy CAD systems, spreadsheets, and slides. Resource planning and optimizing resource utilization, both human and machine, can be quite a daunting task, especially when the real production doesn't exist yet. Let's see how dynamic charts can help in this regard. Dynamic charts such as these help users analyze simulated resource utilization statistics for the given production conditions. These statistics result from the simulation of a production flow, employing machinery and equipments modeled to replicate the specific manufacturing capabilities of a given factory. These dynamic charts can also be used to analyze simulated resource utilization statistics for human resources, i.e., operators on the shop floor. In this scenario, we see operators working at assigned workstations, and in some cases also transporting material between workstations. From what we previously saw, based on the bill of process from Capital we've fed this digital twin of production with, each workstation has assigned tasks. But there could be several other factors like the production layout and flow that influence how a certain resource is utilized in the shop floor. Analyzing resources in such detail might not be possible unless there are physical tryouts or prototypes. Whereas these dynamic charts, for example, can be really helpful in identifying the share of non-value-added tasks performed by a specific resource just by the click of a button. All of that virtually. Here, for example, we have a first operator moving material from one subassembly workstation to the next. A second operator is then seen transporting material to the final assembly lines. It is quite obvious in this case, the second operator has to cover a long distance returning to his workstation. The tool hence enables users spot such potential for optimization early in the planning phase and lets manufacturers produce more with the given resources. Just like the previous use case with analyzing resource utilization, analyzing material flow and identifying bottlenecks early in the planning phase can be quite the challenge. This is where plant simulation could help. Sankey diagrams enable users quickly visualize the amount of transported materials and lets them easily identify potential transportation or logistical problems. In this case, the Sankey diagram shows material flow between the subassembly workstations and to the final assembly lines. A thinning of the Sankey line along one side of the final assembly stations indicates a potential material flow problem in that area. But at this point, we do not know what is causing the problem and where exactly it is happening along that line. For this purpose, we might need additional information, and this is where the bottleneck analyzer could be of help. The bottleneck analyzer helps identify bottlenecks at any time through a graphical representation of the utilization at each resource. It helps detect and eliminate problems that otherwise would have required costly and time-consuming correction measures. Using this functionality in our use case, we are now clearly able to see a potential bottleneck at the first workstation. In reality, there might be several factors causing such a bottleneck, like for example, an overloaded workstation caused by additional tasks from harness variant combinations produced on the same line. In our case though, further investigation shows that the operator assigned to that workstation is modeled at a lower operating efficiency, indicative perhaps of a newly trained personnel. In this case, remedial measures might be required to avoid this bottleneck during production ramp-up. So it's very clear that a data-centric digital twin approach in the context of the wire harness business lets all the stakeholders involved in the development of the bill of process, calculation of labor times, balancing of tasks, and simulation of production always have the right information. And not only that, the digital enterprise integrates both the product and production lifecycle seamlessly to enable a continuous loop of optimization. To summarize what we've seen today, tackling growing product complexity and costs while working with disjointed systems and outdated processes can hugely impact quality and profitability. We can help you transform these challenges to competitive advantages by replacing disjointed systems with data-centric and integrated workflows, and by replacing outdated processes with digital twins and a closed loop for continuous optimization. Siemens Accelerator can clearly help you digitalize your wire harness businesses and become true digital enterprises with speed and at scale. We have now reached the end of today's webinar. Thank you for your participation. Please use the user interface to let us know if you have further questions. Or, alternatively, you can reach out to me directly by email. Thank you.